Hi, welcome to EC&M Tech Talks. This is a series of how-to videos where we explore everything from basic electrical theory on up to the equipment that we install and have to maintain along the way, and to the different codes and standards that apply to us for both installation and maintenance and safety practices as well. In fact, that's what we're going to be talking about today, some specific type of safety. This EC&M Tech Talk video is brought to you by Electrical Construction and Maintenance Magazine. That's EC&M Magazine. Now, if you haven't done it already, what you need to do is you need to go to ecmweb.com. That's ecmweb.com. And if you look up in the left-hand corner, there's a drop-down menu. And the very first line on that drop-down menu is going to be for premium content. And you want to click on that premium content. It's a members only section. Here's the good news. It's free to join, and there's tons of information there for you. In addition to this video, you find related articles, webinars, and so forth, and lots of other information that has all to do with our electrical trade, things we end up doing out in the field. So anyway, so welcome. I am Randy Barnett. I'm your host for today, your facilitator. And today we're going to be talking about electrical safety, but in terms of medium voltage. Now, if you've happened to seen a previous Tech Talk video, we talked about electrical safety in general, but today we're going to talk about specifically for medium voltage. And the first thing we might ask is, well, what is medium voltage then? If we look at the IEEE C84 standard, that's the IEEE standard that defines voltage levels for us. And medium voltage really goes everything from 1,000 volts, or over 1,000 volts, let's say, on up to 69,000 volts. Now, in our facilities, we typically don't bring 69,000 volts into the facility. That stays outdoors in the substation. And we end up bringing in lower voltages through a transformer into the buildings then. What are those voltage levels? And the answer is it depends. They vary. It might be 24,500 volts. It might be 13,800, 13,200, 4160 volts is very common. We use a lot of 13,800, 13,200, what we would call 13.8 kV and 13.2 kV, and a lot of 4160 for distribution systems in our facilities. So if you're in a campus style facility, like maybe a college campus or a large office complex, going throughout many buildings, military installations and so forth, you may be using a lot of medium voltage. Also, where else we're going to find a lot of medium voltage is in manufacturing, industrial plants, refiners, and so forth, any place where we have a big need for electricity. It just makes more sense to bring in electricity at a higher voltage and keep the current flows down low and distribute that voltage throughout the facilities where we need it. And then when we get to the utilization areas, we're actually going to utilize that electrical energy, we'll step the voltage down through a transformer. That all brings us to the beginning of our safety then with medium voltage in terms of the risk assessment, because that's going to be the first step. Now, if I had to go change a tire, let's say I'm going to go change a tire on my good old 51 Ford pickup. That's pretty easy. I mean, it's a little work, but there's a big wheel well there. It's easy to get to the tire, plenty of room to get under there and jack it up and so forth. And I changed the tire. That's a lot different than changing a tire, let's say, on a 18-wheeler or a Corvette, or how about a NASCAR race car, huh? So the objective is still the same. I still want to change the tire out. I want to remove the tire and replace it. But the difference is the application and the tools that I'm going to use. So that's what we're talking about today when it comes to electrical safety. It's still the basics. We don't want to get shocked or electrocuted, certainly, and we don't want to get burned by the electricity. That's what we're trying to protect ourselves against. What we often hear in industry, is a lot of that shock and arc flash and arc blast. If you go back to the other Tech Talk video, you may remember that most of our entries come from shock, not from arc flash and arc blast. Now, let's talk a little bit about the risk assessment then when it comes to medium voltage. First of all, some of our numbers are going to change. If you have the arc flash warning labels on your equipment, certainly you're going to use those. The arc flash warning labels will either have the incident energy levels, at a certain working distance, or it will have the PPE category method for you. And of course, it'll also have the voltage information there. 4160, for example, is very common, as we said. So at 4160 volts, we would expect to see, as far as shock protection, we would expect to see, in fact, all the way up to 15 kV. So really, a lot of what's going to be in your facilities in medium voltage then. For shock protection, we're going to see that there's a limited approach boundary at 10 feet, 0 inches. And that is to expose movable conductors. And we think of those as overhead conductors. And so you may have some of those around for part of the distribution system around your facility. As far as fixed circuit parts are concerned, the limited approach boundary for our medium voltage levels on up to 15 kV then is going to be 5 feet, 0 inches. And what does 5 feet, 0 inches mean to us then? That's the distance that if we get within 5 feet, 0 inches of a live exposed, in other words, the door is open, energized part, is considered to be an area where there's possible shock injury. And so we want to make sure that we keep all unqualified people out of that limited approach area. Now, with one exception, if I've got somebody coming in there to watch me do some work, I can keep them within that limited area as long as they're dressed out appropriately. And then maybe the unqualified person we're attempting to train, but they're not allowed to actually physically do any work. The second boundary area is the restricted approach boundary. The restricted approach boundary for all of our medium voltage levels, anything from say 1,000 volts on up to 15 kV, is going to be 2 feet, 2 inches for the restricted boundary. Anything I take within 2 feet, 2 inches has to be insulated. So let's talk about some of these things. First of all, for shock protection, one of the basic, rubber goods, right? And we think of as far as the basics is our rubber gloves. And rubber gloves, these are larger than what you may typically use, a little bit thicker rubber. So if you're using class 0 or 00 gloves, class 0 up to 1,000 volts, these class 2 rubber gloves will protect us all the way up to 17,000 volts. Now, I don't have to memorize that because all that information is on the label. The label is also color-coded, but it tells me max use voltage, 17,000 volts AC. And like all rubber goods, they have to be inspected within the last 6 months. And you can look in your information on 70E about if the gloves have been sitting on the shelf for up to a year and so forth. But I have to test them every 6 months, send them out to be tested, and daily before use, I have to visually inspect my gloves. So none of that really changes. What has changed is the tool that I'm using. I'm going to a heavier type of glove, a thicker rubber then. So for instance, the class 1 gloves, now these are class 2, I said, good to 17,000 volts. Perhaps, depending on what you're using, you might be using the class 1 glove. And the class 1 glove is good up to 7,500 volts AC there. So perhaps on your 4160 systems, you're using a class 1 rubber glove. So you have to inspect the rubber glove, and you also have to inspect the leather protector as well. And the same rules apply, even though it's medium voltage. I have to make sure that I have adequate distance between the end of the rubber glove the end of the rubber glove and the end of my protector. And that area, we sometimes call that the creepage distance, but you can look at the specifics in the NFPA 70E standard. There's a table to tell you at the different glove ratings what that area must be, the minimum distances in. And so we do our standard visual inspection on these gloves. We also do an air test. We trap air in them and listen for leaks, see if we feel any air leakage and so forth. So the rules for our medium voltage gloves really don't change than what they are for the low voltage gloves, just a different tool then. Now, also for shock protection, we said anything that if we're going to get within 2 feet, 2 inches of any exposed, energized circuit part, we have to have whatever we take in there has to be insulated. So we just talked about our rubber gloves. Something else that we're going to use that we've seen in previous sessions is we're going to use insulated live line insulated tools. And this is an example of one. This is called a shotgun. And we've seen this operate before, but anyway, it allows me to go ahead and I have a hook on the end now. I can grab things and do work. And we're going to talk about this. Part of the lockout tagout process for medium voltages, we must install personal protective grounds. Now, all of these live line tools, they're insulated at 100,000 volts per foot. And then they get tested every 2 years at 75,000 volts per foot. Also, something else we'll go ahead and mention that's commonly used out in the field, another live line tool is the rescue hook. And so the rescue hook, it's also insulated, as I mentioned before, for medium voltage work. And it just has, this is steel, over the steel hook is rubber. And that will hopefully help us if we have to rescue some or move some live conductors from somebody that's being injured and so forth. And so follow your company procedures. You're required to have rescue training if you're the person on an annual basis, if you're the person who's going to be out there and having to rescue someone. Now, as far as other protective items that we identify during our risk assessment, that's going to protect us from the shock, but we also need to protect ourselves from any burn injuries, any arc flash injuries, right? So we have different items for that. And typically what you're going to find is, okay, if you're using the arc flash warning labels on your equipment, that's great. Then you have to dress out for whatever the incident energy is on that label. If that label says 5.6 calories, your arc flash clothing must be rated for at least 5.6 calories. And it's probably going to be rated at something even greater than that. If you're using the table method, in other words, if you have not yet done an incident energy analysis on your facility, you're going to find that you're going to have to use the category method, the table method. And all of our medium voltage equipment there, with the exception of arc-rated switchgear, which would not require any PPE if the doors are latched and secured to rack a breaker in or out. But if you're going to do any other type of medium voltage work, what you're going to find in that table method is it's going to end up being PPE category 4. So for PPE category 4, we end up having to wear arc-rated clothing rated for a minimum of 40 calories. So we end up with a hood, something like this, where the face shield is rated for 40 calories. And then, of course, all of the garment material is rated for 40 calories as well. Now, of course, you're going to do your regular inspection and so forth, make sure everything works properly, is not damaged and so on. You do want to look at the specific label. Don't go by what's just on the outside of the garment. When you look in the label, you're looking for one of two items. Either the arc thermal performance value, the ATPV, or the energy break open threshold, which is the EBT. And you're going to use the lower of those two numbers in order to determine the arc rating of your garment. But I can tell you from the real world, probably 90% of the time or better, when I've looked in garments, I find just the ATPV rating. And so you'll want to use that and do a visual inspection. Now, this, of course, is a pretty heavy-duty suit, and you can see it says on the bib coveralls they're rated for 40 calories. So these are bib coveralls. I would put them on and bring suspenders over my shoulder and so forth, and I'd wear these. Now, once again, it's going to have the rating on the inside. I'm going to do my visual inspections, check for anything that's flammable, no dirt, no grease, no oil, anything like that. Make sure that they're clean, and no physical damage. I keep emphasizing that. And for as far as washing instructions, follow whatever your manufacturer tells you to follow. And so things like no chlorine bleach, because that'll damage the flame resistant properties of the garment. No fabric softeners, because that is flammable, and so on. And also, you don't want anything that contains hydrogen peroxide. So some of our stain removers that we spray on a stain, when we mix those with water, they form hydrogen peroxide. They're great at removing the stain, but it also can damage the arc rated rating on your garment, and you don't want to do that. So follow your manufacturer's instructions as far as ratings on your, or as far as washing your garments in. And the same is true. The arc flash suit will also have a jacket with it as well. There's a label on the inside for me to check the ATPV rating. One thing when I put it on is I want to fasten all of the snaps and so forth and buttons or zippers or whatever it has. But I want to make sure that it's also gives me adequate room for movement and visibility. If not, I'm not going to want to wear it. And we want to make sure that people wear their arc-rated clothing. So it needs to fit properly, it needs to be donned properly, and of course, it needs to be properly rated and visually inspected before use. One of the things that we want to do after we complete our risk assessment, where we have gone through, we've looked at voltage level, incident energies or PPE category method. We selected and inspected our PPE now, and now we're ready to go out, set up our barricades and go to work. When it comes to setting up our barricades, in other words, the physical obstruction to keep people away, we either want to set it at that limited approach boundary we mentioned earlier of at least 5 feet away for medium voltage where the conductor parts are fixed, or we want to set it at the arc flash boundary. Whichever of those two distances is greater is obviously where we want to set the physical barricade so that people do not get injured then. Because we have a responsibility as a qualified person, not only to protect ourselves, but to protect the unqualified as well. We have to keep that in mind. It's an important responsibility. So we set up a physical barricade at the furthest of either the limited approach boundary or the arc flash boundary. We'll put on our PPE and then we're ready to go to work. Now, we always want to follow our safe work practices when it comes to medium voltage, as far as standing aside and opening any cabinet doors and so on, alerting other people and all those things that we would normally do when it comes to electrical safety then. When it comes to medium voltage though, we're not going to take, we never, ever, ever, ever are going to take a meter and try and go in and measure or verify any circuit de-energized. The NFPA 70E allows us above 1,000 volts to use non-contact instruments to go in and verify a circuit de-energized. So what we can do is we can use something like this and attach it. Actually, it would go on the end of our hot stick, right? Our live line insulated tool or shotgun, whatever we want to call it. And this particular device will read all the way up to 230,000 volts. And so I take and I turn it on and it will beep. And if you can see the little light flashing. Okay. So what I want to do is I want to take and put it up against a known source of voltage and make sure that it is working properly on voltage. Then I want to go in and test for the absence of voltage. And then, of course, the third point is I always come back and make sure that my voltage detector is still working properly. So it's still that 3-point live dead live test, even though I'm working at medium voltage. Now, I have not made any contact at this point. I'm certainly not using a contact multimeter. I'm just using a voltage detector where I don't actually have to touch anything, just get close to it to see if I have voltage present or not. So in order to create that electrically safe work condition at medium voltage, I have one additional step I have to do. I'm going to have to install some personal protective grounds, okay? And these are kind of big and heavy and clumsy. They're going to be a minimum of 2-watt cables, but they have clamps on them that are going to assist me. Now, this is still category 4 work. Just because I've verified the absence of voltage with a voltage detector doesn't mean I'm ready to take off my PPE yet. Not until I've installed, or as we say, hung our personal protective grounds, temporary grounds then. Now, these particular grounds, I'm going to have one just for the ground clamp. And if I don't have to actually attach it to bus work, what I have installed in much of my modern switchgear now is I'll have a ball already mounted on the grounding bus. And then this is just like a trailer hitch. I just put this over the ball and then I tighten it down. And then that gives me a good firm connection to ground. Then I want to make sure that I'm using my live line tool. And now I'm going to take a hold of the next clamp, which is going to go to my bus bar. And so this is a flat type connection. So it's easily, well, not easily in a 40 calorie suit and a live line tool, but it'll go over the bus bar because it's a little tricky, by the way, this thing of hanging grounds. Because I think I've said before, it's both an art and a science learning how to do it. but a lot of practice. But so I put this over my bus bar, then I tighten it down with my live line tool, and of course get it good and tight. And then I have to do the same thing for phase A, phase B, and phase C then. Now, when I take them off, I always want to take my phase clamps off first. The last clamp to come off will be my grounding clamp. But when I put them on, it's always the grounding clamp that goes first, and then my 3 individual phase clamps. Other items we have to consider then are the same really as for any electrical safety work. I have to look at the, make sure that my equipment is suitable for normal operation. And so that's those 6 points that are in 70E, where it talks about the equipment's been properly installed and maintained, the doors are closed and secured, and all the covers are in place, and it's used in accordance with the manufacturer's listing and labeling and all of those requirements, as well as there's no signs of impending failure. And that comes with experience and knowledge and training, learn how to inspect that equipment for normal operation. So that's a whole separate issue but you definitely need to be cognizant of that anytime you're going to work on medium voltage. So that in a nutshell is medium voltage safety then. What you've got to remember is the safety requirements are still the same. I always want to create an electrically safe work condition whenever possible. But in the process of doing that, I have to remember, as far as I'm concerned, that equipment is still energized, even when I'm verifying it de-energized. So I need to wear the appropriate PPE. If I'm using the table category method, that's almost always going to be PPE category 4. If you have the incident energy analysis done, you have the labels on your equipment, use the labels on your equipment to determine your PPE levels. Then you need to inspect your equipment for normal operation. You need to determine your boundaries. You need to set up a barricade at either the limited approach or the arc flash boundary, whichever one is greater. Use your live dead live test to verify any circuit de-energized, and you're ready to go to work. And so once again, we're about out of time. So anyway, I hope you've been able to pick up a few things today, or at least review a few steps when it comes to being safe around medium voltage. Because remember, the higher that voltage, the more electromotive force, the more pressure we got to push that electricity. And we can push a lot of energy with 4160 volts or 13.8, whatever it is, as compared to say 480 volts in that given amount of time. So anyway, be safe out there. This EC&M Tech Talk is brought to you by EC&M Magazine, which is a part of the Endeavor business portfolio, and work safely.